Finding trig values using the unit circle. So what I did over on this side of the board was I just drew the first quadrant. So this is quadrant 1. Of course, you kept going around the circle 2, 3, 4, but I just drew the first quadrant of my unit circle. My trig values obtained in that first quadrant of the unit circle at pi 6, pi 4, pi thirds. A reminder that cosines x, sines y, tangents y over x. And then if you're a lot better with the, just kind of reminder here of our two special triangles, I put those two down there. But we're going to focus on working with those unit circle values. Now what we want to be able to do is be able to use what my base knowledge is and take that further to be able to come up with something else. So in other words, if I know through the triangle, through the unit circle, through memorization, that the cosine of pi 6 is root 3 over 2, then I should be able to find the cosine of any angle over 6. So if that reference angle is pi 6, it's going to be related back to this guy right here. Right? The way that I want to think of it is reference, value, number one rule in trig, where am I, meaning what quadrant am I in, then I can determine positive or negative. So let's kind of play with those cosines for a minute. I'm going to say I want the cosine of 7 pi 6. Okay. Now, memorizing, say, an entire unit circle, sometimes it's just too much to ask for, and it's really a pain, and it's not worth it. If you can just know what your base values are, you can make the translation to other parts of the circle. So when I look at cosine of 7 pi 6, my thought is first the reference. Well, I can see the reference right here. It's pi 6. See that right away. So then my thought is, well, what's the cosine of pi 6? Well, cosine of pi 6, x coordinate, or off the triangle, whatever's easiest to you, is root 3 over 2. There's my cosine value. Now I think, where am I? So this is kind of going back to the initial part of trig. Where is 7 pi 6? That is quadrant 3. So we're sitting in quadrant 3. And then the question becomes, well, is cosine, which is x, positive or negative in quadrant 3? And x's are negative in quadrant 3, so it would be negative root 3 over 2. Now I'm going to give you a different pi 6 one. Cosine 11 pi 6. And this gets a lot quicker the more you do, but it's just working that process. Everything's a process. Reference. I see the 6, pi 6. Cosine of pi 6, well, that's root 3 over 2. Okay. Where is 11 pi 6? 11 pi 6 is in 4. Since 11 pi 6 is in 4, cosine, which is x, is positive in quadrant 4, so it would stay just positive root 3 over 2. So I'm relating back to some of those algebraic pieces. So again, once I know I'm in quadrant 4, I know cosine's x, so I'm thinking, well, what is x in quadrant 4? And that would be a positive value. X's are positive in quadrant 4, so they're going to stay that root 3 over 2. Okay. If it helps you, we can do a little grid like this. We know all x's and y's are positive in 1, x's are negative in 2. Both are negative in 3, and then x's are positive, y's are negative in 4. That's what I'm referring to when I'm saying, hey, we're in 4, cosine's x, is x positive or negative? It's positive sitting in 4. Okay. We're going to stick with that pi 6 one just a minute, get some practice here. Let's go with the cosine of 13 pi 6. So as soon as I see the 6, pi 6, I know it's root 3 over 2. I've got that part. So cosine's still at root 3 over 2. Now I'm thinking, where am I? 13 pi 6 would be all the way around. One more, so I'm up in the first quadrant. Cosine's positive in the first. Let's get a negative one in here. Let's go cosine negative 5 pi 6. The negative's not bothering me. I'm still looking at the reference angle. So if the reference is pi 6, cosine of pi 6 is still root 3 over 2. That hasn't changed. There's my value. Negative 5 pi 6, I'm thinking of where I am. I'm in quadrant 3 if it's negative 5 pi 6. So coming back around negative, I'm sitting in quadrant 3. Cosines are x's, which are negative in 3. There's that 4-step process I'm looking at. What's my reference? What's my value? Value is the newest piece. I've got to be able to get my values. Then where am I determines the positive or the negative. Let's get some others up here. 5. Let's go sine of 5 pi force. So again, my reference angle is that pi force. So as soon as I see the pi force, I'm thinking sine of pi force. That's the y value. Root 2 over 2. If you're more of a triangle person, opposite, 1 over root 2 is root 2 over 2. Got my value. This should be the toughest part. Where am I? 5 pi force. 4 force is halfway, so I'm sitting down in quadrant 3. Sine, which is y, is negative in quadrant 3. So we'd have negative root 2 over 2. Let's go sine of 2 pi thirds. Denominator's key. My reference is pi thirds. Sine of pi thirds. Y value, root 3 over 2. Where am I? I'm sitting in quadrant 2 now. Sine, which is y, is positive in quadrant 2, so it's just going to stay there, root 3 over 2. How about sine negative 7 pi 6? The negative's not bothering me. I'm trying to figure out the reference first. Reference is pi 6. Sine of pi 6, 1/2. Pi 6, 1/2. Opposite over hypotenuse. I know the value's a half. Again, that should be the toughest part to kind of work through, is getting those pieces there. Now, where am I? So I'm coming backwards. 6, 6 is halfway around. I'm in quadrant 2. Quadrant 2, positive. Stays a half. Okay. So remember, cosines x, sines y. I'm working with my values. Let's go cosine of 11 pi thirds. So I switch back to cosine. Pi thirds. X value at pi thirds. 1/2. Your triangle, adjacent over hypotenuse, 1/2. And again, this takes quite a bit of practice, just working through the process. Where am I? Well, let's see, 3 thirds, 6 thirds all the way around, 9 thirds, 12 thirds, back up, I'm in quadrant 4. I'm sitting in quadrant 4. Cosine is x is positive in quadrant 4. These pieces I'm looking at. Now let's look at some tangents. Right? Now for us, typically what we want to run into is the fact that, hey, we get pretty quick with sines and cosines. They're going to be the fastest ones for us. Tangent will be a little slower at, but we can work the process. So let's go tangent of, I don't know, let's go 5 pi thirds. Make one up here. Tangent of 5 pi thirds. So tangent of 5 pi thirds, reference. Where am I? Tangent, 5 pi thirds, that value. Here's my pi thirds. Tangents, y over x. So root 3 over 1 is root 3. I'm a little slower on the tangents. Pretty normal when you're first working with it. If you're triangling, opposite root 3 over 1. Where? 5 pi thirds is quadrant 4. If I'm in quadrant 4, tangent is negative. Reason it's negative, remember it's y over x. So if the y's and x's are opposite sign, then it's going to end up being a negative. If I did tangent 5 pi fourths, tangent 5 pi fourths. So pi fourths reference. And I have root 2 over root 2, which would just be a 1. Where am I? 5 pi fourths is quadrant 3. So if I'm sitting in quadrant 3, look at the x's and y's, they're both negative. So I'd have a negative divided by a negative is a positive. Those pieces there. And let's look at one more tangent here. Let's go tangent. We didn't do a 6. Let's go tangent 5 pi 6. Reference angle still 6. So looking right here, reference angle still 6. Y over x, 1 over root 3, which in this case I can rationalize that to root 3 over 3. I'm thinking 1 over root 3 first. I can rationalize it. Now where am I? 5 pi 6 is quadrant 2. And tangent in quadrant 2 is negative. Because the signs are different. Y over x should have a positive divided by a negative is a negative. That value there. And that's the basics of working with it. There's some things that would help you. Okay, here's some things that are going to help you. First off, if you're not so much of, say, an algebraic person, a lot of students like to think of something like this. If I said, what is positive? Right, sometimes this can help you. What is positive? ASTC. Typically, if you're in a trig class, you're most likely going to calculus. So what we say is all students take calculus. This is kind of an acronym to help us remember. So what it's really saying is all of them are positive. All of them. All your three primary functions, sine, cosine, tangent, are positive. Second quadrant, only the sine's positive. Notice only the y is positive. Third quadrant, only the tangent, because tangent would be a negative divided by a negative, making that a positive. Fourth quadrant, only the cosine positive. So trying to give you some things to help you out. I don't really advocate which way is best or worst. I know for myself, I work a little bit more of an algebraic piece. Just something I'm used to a lot more, but I'm not going to say that this is better than this. It's just more of what you think. Right? A couple things that you will run into is, instead of being asked for sine, cosine, and tangent, sometimes you're asked for cosecant, secant, and cotangent. Right? Don't let those get to you. If sine's positive, cosecant's positive. If cosine's negative, secant's negative. Just remember they're reciprocals. So for example, when I'm first learning this, if you asked me to find, say, the cosecant of 7 pi 6, when I see cosecant, unless it's something that I've just memorized and gotten down and I'm going to assume that we haven't yet, I'm going to think of the sine of pi 6. Not the cosecant. I know the cosecant's a reciprocal. So the sine of pi 6. By thinking of it this way, it's back to what I was doing before. Reference, pi 6. Value. Sine of pi 6 is a half. So that means the cosecant is 2. Reciprocal flips over the half. Where am I? 7 pi 6 is quadrant 3. Sine, which is also cosecant, positive or negative, in quadrant 3 is negative. Y value is negative, or you're thinking this, only the tangent's positive. So I'm using the sine value to help me with the cosecant. Let's say we wanted the secant of Let's go secant of 5 pi thirds. Secant of 5 pi thirds. Well, what I'm thinking of, again, I'm getting used to this and I'm going with what I know best. I know cosine's better than secant, so I'm thinking of cosine of pi thirds. So cosine of pi thirds would be a half, which means then the secant of 5 pi thirds is 2. There's my value. Where am I? Well, I'm in quadrant 4. Cosine in quadrant 4 is positive, so the secant is positive. So again, use your base functions to help you when you get one of the reciprocals. Another thing that's going to happen to us, okay, we do see radians more than degrees, but we still see degrees. If I want, say, the sine of 300 degrees, the difficult piece a lot of times is going to be the reference. When we're in radians and we have a fraction over 3 over 4 over 6, the reference is pretty simple. If I see 7 pi over 6, the reference is pi 6. I see 5 pi fourths, the reference is pi fourths. I get in degrees, okay, it's not in a fraction, it's a little bit harder to tell what the reference is. So I have to go back to thinking about what the reference is. I am actually 60 degrees from the x-axis, 60 degrees from the x-axis, so my reference is 60. So then here we go. Value, what's the sine of 60? Well, sine of 60 is root 3 over 2. Where is 300? Well, 300 is in quadrant 4. Is sine positive or negative in quadrant 4? Sine's negative in quadrant 4. So if I'm in a reciprocal function, cosecant, secant, cotangent, it slows me up a little bit because I need to figure out the base function first and use the reciprocal value. If I'm in degrees, slows me up a little bit on finding that reference. And that would be the part that gets me. But once I have it, I'm just back rolling through the same way. So there's some little things that show up that slow you up, but it doesn't change the process. I need this reference and I need the value first. I'll figure out where it is, and then I can deal with the positive or negative. Okay. The other piece or last part that shows up here, if I'm going to say, what if we're on the axis? So in other words, sine of pi. Okay. Sine of pi. So we're actually sitting on the axis right here, or if I extend this out right here, just remember your x's and y's. All right. If you're on pi, that means you're on the x-axis. Sine is y, so it's 0. Remember that point was -1, 0. But just think, I'm on the x-axis. What's the y value on the x-axis? 0. Cosine of pi, well, that would be -1. Our unit circle, that would be -1, 0. So just like this is 1, 0. Well, here would be -1, 0. The x value is -1. Tangent of pi. The y value over the x value is 0. It's really 0 over -1, which is 0. Let's look at, say, pi halves. Sine pi halves. The y value at pi halves, 1. Cosine pi halves. The x value at pi halves, 0. The tangent of pi halves, this would be undefined. Undefined because you'd have y over x, 1 divided by 0 is undefined. Now notice I didn't say anything about cosecant, secant, or cotangent, just to kind of show you how these work. If I know the sine of pi is 0, then I know the cosecant of pi is undefined. So in other words, remember cosecant's the reciprocal of sine, so if I flip the 0 over, that means the 0 goes to the bottom, undefined. Well, the secant of pi, if I flip over a -1, hey, that's still -1. The cotangent of pi, well, that's back to undefined. Because if I flip a 0 over, it goes to the bottom, undefined. So in this case, Cosecant of pi halves, 1. Secant of pi halves, undefined because the 0 will go to the bottom. Cotangent of pi halves would be 0, not 1, would be 0. So in other words, if this is undefined, 0 is on the bottom. If I wanted the cotangent of pi halves, it's going to move the 0 to the top, so it would be a 0 instead of an undefined. So remember, 0 underneath is undefined. That's how we're coming up with those pieces.